Okay, so first of all, good afternoon to all of you. Why attendance is going decreasing day by day? Only 17 students join. 16, 17. What's the problem? Okay, so in the last session, we seen various examples or problems related to the conductor size calculations for the residential purpose and for the industrial purpose also. So in this session, we are going to see the conductor size calculations for the underground cable. That means we have to find out the size of the conductor for the underground cable. Okay, so for that, which factors are going to be considered while solving the numerical? So in the last Okay, so which factors we will consider while solving the problem or numericals on the conductor size calculations? So the first four factors are similar like the residential conductor size calculations. So in that we were calculating the current carrying capacity of the cable. That means the how much amount of the current flowing through that conductor. Then how much is the voltage drop, or we were compared that voltage drop that we are getting actually. That voltage drop is falling within permissible limit or not. So that we have to check in this conductor size calculations also for the underground cables also. Then next, minimum permissible size. That means the for carrying current um, of less amount also, but we have to select a minimum conductor size. So for the residential purpose, um, current carrying capacity of 10 ampere is the minimum permissible size of that conductor. So here also we have to consider the minimum permissible size of the conductor. So table will be various for the actual that means for the various voltage levels. That means the for the 11 kV voltage levels, conductor size current carrying capacity will be different. That means for the 11 kV voltage level, we have to understand or consider another table, but for the 33 kV we have to consider another table for selecting the size of the conductor. So but in case of the residential purpose, what we did, we just referred a one table for the aluminum, one table for the copper. But in case of underground cable site selection, we have to consider the various tables. That means according to the voltage levels of the uh, transmitting cable, and then we have to refer the table for the resistance per kilometer also. That means the table for the finding the resistance per kilo ohm for particular conductor size is also different. So that two three table we have to refer while calculating the size of the conductor for underground cable. Then it also affects, that means the type of the conductor which we are using, copper or aluminum. Suppose you have to select the copper conductor, then you have to refer the table for the copper conductor size calculation. Then if you have to select the aluminum conductor size, so for that we have to consider aluminum conductor table. So like that. In the residential purposes, or while calculating the conductor size for the residential purpose or for the industrial purpose, we will use the different formulas, like for the calculating the voltage drops. Suppose if you have to calculate the voltage drop for the residential purpose, so which formula you were used for calculating the voltage drop for the residential purpose? 1 plus 2% of the total voltages, and for the industrial purpose 1 plus 5% of the total supply voltage. So like that way, in case of the underground cable, if you have to calculate the permissible voltage drop, so if you have to calculate the permissible voltage drop, that permissible voltage drop should not be more than the 12.5%. That means the you have to consider the permissible voltage drop up to 12.5% of the total supply voltage. Then if you have if you have to calculate the size of the conductor for the overhead purpose, that means the if you have to calculate the overhead distribution or if, overhead conductor, then that that voltage drop should not be more than 5%. Or for the underground distribution line also, that voltage drop should not be more than 5%. So suppose for the transmission of the underground cable, so that question, that answer is given in itself in the question, is that line is for the transmission purpose or for the distribution purpose. So on that basis we will consider the voltage drop. Okay. So these factors you have to consider while calculating the size of the conductor. So first is the current carrying capacity, how much current is flowing through that conductor. So depending on that only, we can select the size of the conductor. Okay. Then voltage drop, we have to check is that voltage drop falling within permissible limit or not. Then minimum permissible size. Then next, which type of the material is used for the conductor. So these all things you have to keep in the mind. If you understood, then we will move towards the next problem. If not, okay. So these are the tables. So this table is for the voltage level up to 11 kV underground cable, and for referring the aluminum conductor. Okay. So next table is for the 33 kV underground cable, and the last one table is for the calculating the resistance of the insulated underground cables per kilometer. Okay, these three tables we are going to consider for calculating the size of the conductor in the numericals. So just take the screenshots at first so that it will get easier to all of you while solving the numericals. After taking this screenshot, just take the screenshot for the 33 kV also. Then resistance of the insulated underground cables. Just take the screenshot of this also. Okay, so we will move towards the next problem. So in this problem, calculate on the basis of the voltage drop the size of the underground cable. So what we have to calculate? We have to calculate the size of the underground cable to be laid for transmitting electrical energy. That means which voltage drop we have to consider here for the transmitting electrical energy. That means the voltage drop should not be more than the 12.5%. That means the permissible voltage drop what will come 12.5% of the total voltage. Okay. So next, what is given here? 11 kV voltage level is given here from substation to a distance up to 500 meters. That means the distance is also given here, and capacity of 300 kVA. That means the power is given in the apparent power. That means the sometimes power will be given in the kilowatt, or sometimes power will be given
Ma'am, you are not audible.
Okay, so I will just tell you the procedure for solving the example. In short, because of the some emergency work, I have to pause this session. So, what are the given quantities here? Voltage is given in this question, 11 kV voltage. Then next, distance is also given, 500 meters. Then power is also given in the apparent power, 300 kVA. So first of all, which formula we have to use? We have to calculate the permissible voltage drop. That permissible voltage drop should not be more than 12.5% of the total voltage. Twelve point 5% of 11 kV. So what is the value here? 12.5% of the 11 kV. Just to fast calculate. 'Otherwise, you can use this formula, 12.5 divided by 100. Into 11 kV. So be quick and tell me answer.
1.375 kV.
1.375 kV. Okay, so this is the permissible voltage drop. The next, so I am not checking if the whether answers are correct or not because of some emergency work. I will just tell you the procedure. Next, you have to calculate the current carrying capacity. That means the how much amount of the current flowing through that conductor. So for that, you have to use the formula for the power. So here apparent power is given. So that means the apparent power means only V into A. That means the voltage into current. So here power factor will not come here. If that power is given in the kilowatt, so at such cases you have to consider the power factor. But here we are not considering the power factor because power is given in the apparent power. So root 3 VI. So just by rearranging the formula, we can calculate the current. So P divided by root 3 into V. So total power is 300 kVA. So 300 multiplied by 1000 root 3 into 11 kV into 11 and for K. So this 1000 will get cancelled with this 1000. Now tell me answer.
$15.74.
15.74, correct? 15.74 ampere. Okay. Now we have to consider the overload condition. So for the overload condition, how much percentage we will consider? We will consider 20% of the overload. So that allowing overload of 20%, allowing overload of 20%. Just ignore my handwriting. Allowing overload of 20%. So we have to consider current also 20% more than the actual current. So how much is the actual current? 15.74 something. 15.74 multiplied by 20%. So how much current it will come? 20% of the 15.74.
3.15.
3.15, correct. So this much amount of current will be greater. So while considering the total current, we have to add this 20% current into the actual current flowing. Total current is equal to total current is equal to 15.74 plus 3.15 is equal to how much is the total current?
18.9 ampere.
18.9 ampere. Okay. This is through one phase. Okay. So total current will be multiplied by 3. Okay. This is for the one phase. Total current will be multiplied by 3. So according to that, we have to select the conductor size. So 18.9 multiplied by 3, how much conductor size we will require? 18.9 multiplied by 3.
56.7 ampere.
56.7 ampere. So for carrying that much of amount of the current, we have to select which cable? This first one cable. Always you have to consider for current voltage level of the conductor. So that's why we are not using single core cable. In case of the underground, up to 66 kV, you can consider the 3-core cable. Okay. And we are calculating for the underground cable. That's why just take this column, which column you are selecting. So the current rating for cables in the ground, that means the for underground and 3-core armored cable. So for that reason, we can consider size of the conductor up to 25 square mm. Okay. By referring table, this sentence you all know, because of the time limitation I will not tell. By referring the table, we can select the conductor size of 25 square mm, 3-core armored aluminum conductor. So in this way you can write the sentence. Okay, so you can select the conductor size of 25 mm square, 3-core armored cable. Okay. 3-core armored aluminum conductor. For the aluminum, I will write Al conductor. Okay. So then you have to check. So in the residential case, you were calculating the voltage drop by using another formula. But in case of the transmission and distribution, you all know the voltage can be calculated by voltage drop can be calculated by I into R. So here you can calculate the actual voltage drop by this formula root 3 I into R. So this formula you have to use, but here R is not given. That means the resistance of the cable is not given. So what you have to do for calculating this formula, you have to check the resistance of the cable. So for this particular 25 mm square cable, how much is the resistance per kilometer? You have to check resistance for calculating the 25 mm square here. This is the size 25 mm square, and we have selected the multi-core cable. Okay. So here maximum allowable resistance. So this 1.102 we have to take into the consideration. 1.102. So this is the resistance. Okay, 1.102. Now this is the per kilometer. That's why we have to calculate the resistance for the 500 meter. Okay. Then we will calculate the R is equal to 1.102 multiply by how much is the total distance? 500 divided by 1000. This zero will get cancelled, this zero. Then how much is the resistance for 500 meter distance? 5.51. No, it will come 0.51, I think.
0.53 ohm.
0.51. Okay. So next, you have to put this value in this formula. Root 3, how much is the current per phase? It is 18.9 multiplied by 0.51. Root 3 multiplied by 18.9 multiplied by 0.51.
16.69
16.69
volt.
16.69 volt. Okay, now we have to check, is that voltage drop falling within permissible limit? That voltage drop is below 1.375 kilovolt. Okay, so that's why we don't have problem to select the above cable that we have selected by referring table. We have selected the 25 mm square 3-core armored aluminum conductor. So we can select this conductor because this voltage drop is falling within permissible limit. Okay, so all of you are requested to take the screenshot of this question and just try to solve by yourself. Because of the some work, I will end our session here itself. So you just calculate the answer, and tomorrow I will ask you randomly anyone the procedure for solving the numerical. So at that time you have to tell me the procedure for solving this numerical. Okay, so I will change the values here and you have to tell the procedure for solving the numerical. Okay. Just take screenshot fast. Have you taken screenshot? Okay. Have you taken the screenshots for the table? Screenshots of table. For 33 kV, then for 11 kV. Okay. So I will end our session here itself. You have to solve that numerical and tell me the procedure tomorrow. Okay. So thank you for joining the session.